Hi, good day to you. Okay, Dr. Shiva here. Today, for the PPKBSM student, material and mineral students, I would like to conduct a tutorial for PDE, and which suppose I should upload it today because of unexpected circumstances. I wanted to on hold this tutorial, and then today I would like to conduct with you the tutorial PDE, and this will be a recorded version, and I hope that you can follow me for the PDE. And since you have done your PDE for in the lecture, I hope that I can glance through certain aspect of PDE in detail. Hope you can follow me. As usual, please take a pen and paper. Just follow whatever that I'm trying to write, and if you have any difficulties, I will try to have discussion with you maybe next week time. Okay, we can have a one hour chat, okay, regarding the tutorials. Okay, PDE, as you all know, PDE is a partial differential equation. I know that PDE is not one of the easy subject to understand, but I'll try to cover with you, okay, in detail how to solve PDE problem, okay, especially the heat and wave equation. Today I will cover the first session with you. Hope that you can follow me. Okay, without wasting any other time, just I will explain to you. Okay, first of all, PDE, partial differential equation. Okay, what is partial differential equation? Okay, first thing, partial differential, the definition I already given to you earlier last semester. I won't go into detail for the partial differential, but okay, what is partial differential equation anyway? Okay, we're going to learn the partial differential equation for the second order. Okay, we're going to learn partial differential equation for the second order. Okay, see whether this is clear or not. Okay, hopefully yes, it's clear. See, okay, D, okay, D. Okay, you can see that G. Okay, now see, this is U, this is C. Okay, this is an equation for the second order, whereby you have seen the combination of X and Y. Okay, that means we are using U, X and Y as our combination. Sometime, because I need to, okay, now we are using this combination of X and Y for the partial differentiation. This is a partial differential equation for the general, for the second order, and you can assume the A, the coefficient for this second equation, E, and F. Let me change this pen. Okay, second order equation in this case, and you can see something here, G. Okay, G will be a X and Y. It can be a combination of an X and Y. Now, when I say this combination of A and B and C and D and E, F, it's actually representing a function, okay? It's not a coefficient by itself. As you know, it's not a constant coefficient, but maybe I'll try to write this as a A5, A4, A3, A2, A1, A0, okay? And this can be represented A as AI xy, okay? AI xy, which is basically is in a function, okay? Is in a function which is a combination of x and y, okay? Combination of x and y. Now if the case is with this is the combination, as I say, okay, 1 2 3 4, okay? Now you can see there is a if let's say g xy equals to 0, we call it this as a homogeneous, okay? Homogeneous, okay? Homogeneous function can be explained in the three way, okay? In three way we can explain that, okay? One, we call it as b2 4 ac 0, we call it that as a hyperbolic function, okay? B will be represented as a b squared 4ac which is equal to 0, we call it this is a parabolic, okay? Parabolic. C will be represented with this b2 4ac less than 0, we call it this as a elliptic, okay? Maybe you may ask that I already included in my notes, and if you look at it look at my notes, then you will know why this is very important understanding. Most probably it won't be emphasized more in much in the general discussion, but I would like to emphasize here there are three, okay? Differential equation, homogeneous equation, which can be explained as a hyperbolic, parabolic and elliptic. This knowledge is very useful. Okay, let me explain to you what is this hyperbolic in the first place. Normally, how do we understand, we can express this hyperbolic, parabolic and elliptic. Normally people will express this knowledge is, they will use a cone to express this hyperbolic, parabolic and elliptic what you call the sketch, the drawing. Okay, normally if we sketch this on the top of the cone and this become a circle, okay, this is become a circle, and slightly we use, okay, slanted, bit slanted, then it become a what we call as a elliptic, okay? Elliptic function. Okay, what is parabolic? Parabolic is something that we can see here, something like this, okay? And how to imagine the hyperbolic? Okay, the hyperbolic is a little bit wider, okay, a little bit wider. You can see this is a little bit wider in the sense that it will be represented as a hyperbolic, okay? Hyperbolic. Okay, now what is the significance of this this homogeneous categorization of partial differential equation? Is there any significance of this? Yes, the usage is enormous, which I in this particular chapter I won't be able to elaborate this into detail, but anyway this simple knowledge is very useful to you to know. For example, I give you some example of hyperbolic and elliptic, okay, parabolic lah, but basically I will choose hyperbolic and elliptic for you to this thing. For example, in optics, okay, in optics analysis, the parabolic, hyperbolic and elliptic design will play the very important role to express certain things, especially the light. Okay, for example, you can see how the reflection of this. Okay, imagine this is a kind of elliptic. Imagine this is an elliptic, but okay, you can see this elliptic partially drawn. Okay, this one is not there. Okay, when the light, the focus will be here, okay, in the middle point, and the light will be when the okay, the reflection of the light will be within. Okay, you can see it's a within the what you call the lens. Okay, here similarly you can see for the elliptic the reflection will be within. But what about the hyperbolic? Hyperbolic, the concept is slightly different. Okay, just because take it this as an analogical thinking. Okay, why we need to learn certain things about hyperbolic, parabolic, and elliptic. It's a lot of difference. We cannot categorize everything into one category. When you see hyperbolic is a slightly wider, you can see it's a little bit wider. Therefore, the focus point here for the this lens, and when it's come to the light when it go inside, it will come outside of this. It's a very surprising. It's go outside of this. Okay, it will go outside of the lens. Similarly, you can see it will go, and it will go outside of that. Okay, this is one way to see some of the application of this kind of knowledge, but we are not going to see this application in this way, but we are going to analyze the elliptic, parabolic, and hyperbolic in a different perspective. We're going to see that in the heat wave movement, and we're going to see that in string vibrations. Okay, we're going to use this in a vibration, and some more heat, of course, in a 2D dimensional concept. Therefore, this is take it as hyperbolic. Just I give you the idea of hyperbolic. Okay, now how to identify the hyperbolic function? Okay, how to identify the hyperbolic function? First, simple. The hyperbolic function can be identified as, for example, you can see, okay, is this which category it will fall into? Okay, this is a TT Okay, simple. Go back to this equation again. Okay, you wanted to accept TT, maybe it not necessary it should be XX. It can be a TT, it can be a YY. You see, Y I can represent as a TT, no problem. Okay, imagine A as a XX and YY as a C. Okay, you can see here, this TT is actually, you can see there is a kind of representation here whereby the C is there. Okay, and for the UXX there is a here, but what is the representation of that? Okay, the A is 1. Why? I can choose here A equals to 1. Is it correct? A equals to 1? No, maybe I'll try to say because it's X is a -1. No problem, no harm. Then I just choose -1 because A is represented by the XX. And what about the TT? TT is represented by C, which is, I call it that as a 1. Therefore, what about the B? Is there B is exists here? No. Can you see there is a combination of the XY? No. Once XY combination is not exist, therefore B is a 0. Okay. Therefore, we'll assume the B is equals to 0. Therefore, okay, since we just calculate and see first, okay, here B squared minus 4AC. What is the results of this? Of course, you can see the combination of this, B is a 0, therefore we get a for AC, whereby if we calculate this as a -1 and C is a 1, therefore is a greater than this 0, it automatically fall into hyperbolic category. Okay, it will fall into the hyperbolic category. Therefore, we know from here this combination will be categorized under hyperbolic. Okay, what about this? Okay, this is very simple. I hope that you all can follow me easily. Okay, ux ut, okay, equals to 0. But no worries, you see there is no combination. We are only looking at the B A C only. We are not looking at the D E F. Therefore, you don't concentrate on this X T. Only you should concentrate here is a A. Okay, the A is a 1. Okay, the A is a 1 and C equals to 0 and B equals to 0. Therefore, when you calculate for this, okay, since it's this AB 0, you will get equals to 0. That means your B equals to 4AC, okay, equals to 0, which represent the parabolic, okay, parabolic category. Okay, I hope that you already got it, the logic that I wanted to explain to you. Okay, similarly, ux plus uyy, this is another important function. Okay, over here you can see looks similar, okay, but is same as that, but only makes difference here is the what you call the sign. Okay, plus sign and negative here, 1 and C equals to 1 and B equals to 0. Therefore, you will get 4, okay, less than 0, which is elliptic. Okay, elliptic. Okay, with this, I hope that you got it. Oh, very simple, right? Okay, very simple to categorize, okay, the homogeneous function into hyperbolic or parabolic or elliptic. Okay, with that, let me move into a kind of quick revision, which I want you all to know all this basic again. A kind of quick revisions, which is, I believe this is a very important to you to know. And one of the things that I want to revise back with you is a total differentiation. Okay, this is very important, total differentiation. I want, okay, you all to, once we see how to write this, at least you should be able to write, okay, dx, or not dx again, sorry, yes, this is partial. Why it become a partial? Okay, is a dx plus del f del y to the dy, and if we go more, okay, it can go even up to 3 these things. Okay, what is my mistakes here? It's not a mistakes anyway. I wanted to say, okay, this is a function of x, y, z. Okay, when I started doing total differentiation for this is what suppose I to get. Is it I made a mistakes? Yes, I made a mistakes here. Can you see this? It's supposed to be z. How do I know? How am I know? Okay, because you see, same. It should be a same. Should be a same. Should be a same. Imagine, don't do that, but you can cut off. You can cut off, you can cut off, you can cut off. You should get the f partial, partial, partial combined together. Okay, the single, full, total. Actually, total combination of this. Okay, this one is clear. We already learned this before. The usage is enormous. We are not going to go through that application of that in detail, but okay, ruled. This is a kind of, again, a revision. Okay, there are two cases, as you know. Okay, case 1, whereby we know there is a single x, y, t. We can combine that together. Okay, if I ask you to write, okay, del z, is it a del z? Correct? Am I writing a del z is correct? To t? Cannot, because it's a single, right? Therefore, it's not a del z. Okay, you just, is it correct? No, this is not correct. Okay, why? Because this is a single variable I'm going to refer to. Therefore, it should be d. Okay, dt. And how to write that? Again, you need to use the combination of xy. See, I just come down like that. Okay, then see z to here. Therefore, the first thing is del z to del x. Why is it partial? Why am I showing, this is a del? Because there are more than one variable. And this is dx. Okay, dx. And what is the combination of this again? Okay, it's a del z to del y, which is dy. Okay, with this combination, is there anything to focus more into? No, I made a mistake here. Suppose I forgot to come down. Okay, d dt, dy dt is not d again. Sorry, d. Yeah. This is a d because it's referring to one single variable. Okay, we should remember this is a partial, or what do you call this thing? This is not a partial anymore. Okay, to say this is a t. Okay, but I want you to have a look on that. That's supposed to be the d. Okay, remember every value which is referring to x is a single variable, is a t. Okay, that means it must be d, must be d. Okay, and if this one z is referring to x and y, okay, that means it's a more than one variable. Therefore, it become a partial. This is partial. Okay, this is, we can see it's not a partial. Okay, therefore, this is the combination that we are seeing here. Okay, with that, can we move further to this? This is something very interesting. This is a case 1. Case 2. What about the case 2? Okay, case 2, we already learned this before as well, and I'm quickly doing this revision, and is st. Okay, okay, I hope that you can follow me. Okay, you can see that very clearly because I worried the camera. Okay, whether you all can see that. Okay, with this we know z represented with the x and y, and x represented with the s and t, and y represented with the s and t as a combination of the independent variables. The independent variables are representing the function of y. Okay, therefore the first combination, if I wanted to take out this x as my term, you see, del z to the del s. Okay, from here to here, therefore I need to come down. Okay, I need to come down this in this path to z to the x, x to the s. Okay, can you see this? This is a very important del z, del x, del x, del s. Okay, both are del. Okay, then del y, del y, del s. Okay, I hope that you can follow this. This is very simple, but the usage, are we going to use this in our lesson here? But I'm revising this because this is a very useful information to you. Okay, zt, okay, is a kind of understanding. This is a very important because when you learn thermodynamic, heat capacity and all these things, it's a very important formulas. Okay, because I hope that you will, in the second year you will learn all these things. Okay, thermodynamic and some other, you may learn that in some other subjects. Therefore, this knowledge is enormous. Please don't underestimate this formula. Okay, therefore the case 1 and case 2. Okay, at least you know how the case 1 and case 2 really works. Okay, with this knowledge, just simple revisions, very quick revisions we have done from the previous semester. The knowledge that we are carrying is a case 1 for the chain rule, and total differentiation. Okay, now let us do one simple example for the verification. Okay, in particularly this topic is very simple. I may say it's simple, but some of you may not agree. You may laugh when I say simple. Okay, you may say, sir, for you it might be simple, sir, but not for us. It's very difficult. But let me explain to you this. Okay, why am I saying this is simple? Because the way that I'm going to, because it look very complex, but when you start follow, and after that, one time, twice, then you'll know already. Okay, there is some what you call the repeating, okay, recurring recurring method to explain the whole formula. Therefore, you will agree with me later and say, yes, there is some recurring formula there, which if I can follow that step, if I can remember, if you can remember, then you should be able to do it. Okay, now, let me show you. Every time in this particular topic, they will ask you few questions only. Okay, few standard question. I will say this is very standard. You follow some example of mine enough, then this will be very standard. Okay, therefore the one of the standard question for the this thing, they will ask you to verify. Okay, they will ask you to verify one of the simple questions. They say, okay, please verify for me. Okay, u x t sine x at. Okay, in this is an example. Okay, the simple question, they will ask you to verify. Okay, if they ask you to verify, then will they say, okay, is it satisfies the del 2 y del t2 a2 del 2 y del x2. Okay, they want you to verify this, whereby this is a solution for this equation. Okay, they are, okay, in another term, simplify the things, they are saying this equation is a solution for this. Okay, once you verify, if it is yes, can be verifiable, then immediately we can confirm this is a one of the solution. I'm saying one of the solution. It could be more than one solution for this. Okay, I'm saying this is a one of the solution for this equation. Okay, therefore you cannot immediately say, oh, this is the solution, therefore it's overall this will be the solution for this equation. No, not necessarily. Okay, since it's a partial differential equation, it can be more than one solution. Okay, now okay, let me, how to do this? Okay, is it a, oh sorry, I put it here y, it's not a y, actually it's a u, sorry. Okay, because of the always we used to write dy dx, right? Okay, now du dy. Okay, now you can see this has become a du dt. Okay, is it possible for me to just change it, this du dt? Can I find out this from here? Okay, maybe I call it, this is equation 1, this is equation 2. Maybe I take from 1, equation 1. If I start doing du dt, what I'll get? I'll get a okay, simple. Okay, it's a sine, therefore I will get a cos x at. Okay, because I'm differentiating this, I need to investigate, I'm doing for the dt. Okay, therefore I'll get a negative cos. Okay, now can I proceed to the second order? Sorry, not a y again. It's because of the norms lah. Okay, now here, if I get it here, similarly I need to differentiate this again. I will get a a2 sine x at. Okay, the same term that I'm going to use for the del u del x. Okay, what I'll get for the same, but this time no, xa x, sorry, why this at, okay. Okay, the next one, if it is a del to the x, okay, where this become again negative sine x at. Okay, substitute this and this here, okay, and see whether am I getting the same results? Yes, of course. When I substitute this as maybe I put it at 3 and 4, 3 and 4 in 2, I will get the same. That means you have done the verification. That means yes, this is one of the solution for these equations, okay, partial differential equation. Okay, with this, in common sense, in the examination or in any quiz, or now you are not going to face examination anymore, but let's say in the test or in assignment, they may ask you to verify the equation, okay. This is how you should verify the equation. Okay, the first method I'm going to teach you now. The first method to solve PDE problem, okay. The PDE problem can be solved with one of the method called, I'm going to teach you only two methods. There are many methods. I'm going to teach you only one. Maybe you can take it this as a method, okay, maybe verify as a one method, direct method. I'm going to teach you three methods, which and one more is a separation method. We're going to learn only these three, okay. We're going to, because the syllabus will cover up to these three method, okay. Integration, direct integration, okay. One of the method is to solve any problem using direct integration. What is direct integration? As you all know, there is a directly we can integrate certain equation, but not all we can directly integrate, okay. Since these integrations, okay, you won't be able to see what I'm trying to solve it here, okay. For any circumstances, okay, if you see, okay, I'll just write this, one of the equation, you go back to the equation, we call it, which one can be directly integrated? That is a one simple question that always people will ask, okay. Direct integration only possible for, okay, only possible for, you can see any non-homogeneous. You can see this is a non-homogeneous. Can you see this equation is non-homogeneous? Okay, it's non-homogeneous because this is a G. You can see this is a G, okay. Therefore, in any equation you can see this as okay, rest all 0. Therefore, we no need to consider there is a G exists here. Can you see this? This combination is this for particular case is a X and T, okay, for X and T. Therefore, G is exists, rest all 0, okay. Therefore, we can see this is a non-homogeneous. When you see non-homogeneous and one equation here, we can solve this using direct method, okay. The direct method, okay, let's say they have provided to you some boundary condition, okay. Later I will explain to you what is boundary condition and initial condition, the difference between these two, okay. 0 t sine t, okay, and another one more is 0 t cos 2t, okay. With this, can I solve the problem? 1, 2, always learn to equate the equation with the numbers. Numbering is very helpful to you because this is a kind of coordination to inform the examiner that this is how you are solving the problem. Please follow this way, the style, okay. It's easier for you to communicate, okay, to the examiner when they see your work, okay. You are saying, okay, I'm going to use the first, okay, from 1, I'm picking from the 1 where I can solve the problem first. Okay, I'm picking the first one. I'm started solving this. Okay, what I can say is u dx2 dx. Okay, same as that, 12x2 t plus 1. Okay, 1, which is dx. This will end up as del y. Wow. Okay, dx, which will give you 12x3 3 x plus 1. Okay, what suppose I need to write? Can I write a c here? Is it right? Can I write here c? No, you're wrong. Why? Because you can see u is actually a representation of x and t. Is a partial. Therefore, partial, when you integrate the partial, you cannot represent that with a constant. Instead, you need to say what is the constant here. Okay, because we are doing for the x, right? Okay, therefore the constant will be t. Very important. Okay, it's a t function. If this constant function, this is a t, is become a constant function. Therefore, when you solve it, this equation, okay, now, okay, you can see the first, we already started seeing, okay, we already come into the second equation. Therefore, I call it, this is a 4. Can I say 2 in 1? Okay, what will happen to in combine as 2? Okay, I place the condition number 2 inside the equation number 4. Okay, once I inserted inside, I will get it very simple. That means it's here x equals to 0. Very obvious, right? X equals to 0. Okay, therefore I hope that you can see. Oh, you cannot see this. Okay, again you can see this x equals to 0. Okay, therefore you can see this x equals to 0, whereby u x 0t, when I place that 0t here, okay, substitute, okay, what will happen? Okay, this become x is a 0. Okay, therefore very straightforward, you get a x is 0, and this equal to the sine t. Very important, when it's become like that. Okay, this phi t equals to sine t. Okay, now we got the new equation for this. Okay, is it possible for me to go one step? Some of you may ask the simple question, sir, why are you starting with the dx? The simple answer is because we are trying to reach to the second, because we are trying to comply these two equations here. Okay, these two equations. Therefore, we don't have other options. You may say, can I start with the t? Can I go for the t? Oh no t here. Sorry, there are both are x. Okay, in this case x. Sometime they may give a combination of t and x. Okay, different. But anyway, in this particular case, then when I solve this for the u, I will get this as a 4x 4 solve it 1, which I'll get a sine t. Okay, you can see that, which is x sine t. Okay, plus what can I write here? Okay, can I place here c? Can I say this is a constant for that? No. Okay, it cannot be a constant. It must be the constant for t again. Okay, but this time we are not going to use phi, but we are going to use something. Okay, maybe theta t. Okay, theta t. Okay, now when you see that for the second, this maybe I call it as number 5. 3 in the 5. 3 in 5. When I place 3 in the 5, I get a solution as what? Okay, again x is a 0, I should place it there as a cos 2. Therefore, when I say x equals to 0, u 0t, okay, which it will give me cos 2t equals to theta t. Okay, as a complete solution, what can I write here? I can write that whole equation as u, okay, uxt equals to x2 x plus 1 plus x sine t plus cos 2t. This is the solution. Okay, this is the solution for direct integration. This seems very easy. I don't think you